Hello, everybody. First of all, thank you very much for taking the time to join us. Much appreciated. This is the first webinar of the year regarding the subject matter of the decade of distributed energy resources, and we hope to have others for you as we go forward. I guess the big question now is why do you want to consider energy storage? I think the biggest reason we're talking about energy storage as much as we have been in the near past is that it's quite obvious we require shifting of the peaks on the grid to help everybody manage not only their own participation in consumption, but also the grid. This is required to really bring some stability to the whole Ontario marketplace. In terms of the energy storage, it's the wind and solar is becoming a little more mature in terms of what they've been doing on the grid. However, battery storage and natural gas generators are certainly more of the current conversation. Of course, the idea of battery storage versus a natural gas generator has a lot to do with the duration of peak shaving, as well as the greenhouse gas emissions. And we can speak a little bit more to that as we go further. Perhaps one of the other major benefits of having a battery storage system is that it provides emergency backup for your facility, ride through some of those shorter term issues that could cause process interruptions. And why is this important in Ontario? I think if you look at the graph here, you can see that the red line is representing what the grid is actually doing, and it can be quite volatile at times. And for most of you who are participants in the ICI program, I think you understand and appreciate the impact of this volatility. And obviously, utilizing some load shifting technologies, we can not necessarily flatten, but we can make the peaks on the grid a little lower and reduce the stress for all concerned. I think with the common knowledge, there's going to be a lot more electrification as a result of these greenhouse gas emissions. There's going to be more demand for electricity on the grid. Another major influencer going forward will be the upcoming nuclear refurbishing, which is happening beginning in 2024. And of course, that's going to have a large impact on the grid. And we all want to contribute to our greenhouse reduction. So helping people utilizing this kind of technology is going to help you reduce those targets. And of course, as we've all experienced, there's quite a fluctuation in the GA cost pool and the inverse relationship of the HOPE pricing to the cost pool that's going to have an impact going forward in the future. Here you can see when we talk about the inverse relationship of the GA cost pool to the HOPE pricing, when GA goes down, HOPE goes up and vice versa. This is a little bit of an indication from the IESO where they see the cost going in the near future. And as we can see here, the GA cost pool is going to drop for a while. That perhaps has quite a bit to do with the nuclear refurbishing and the ending of some of the natural gas contracts that the IESO is obligated to at this time. And of course, then you see the inverse relationship of the HOPE pricing going up. So if you continue to do what you've been doing, the net result is you're going to have less impact on your GA savings than you had in the past, and an ongoing increase your HOPE pricing for the remainder of those times on the grid. There has been a lot of conversation with many folks, and if you're like a lot of companies, this conversation has gone up and down the flagpole many times, and there's been some traditional roadblocks to battery storage that we haven't been able to overcome in the past. Some of those common things are the longer terms, the 10+ year term to acquire the system, the fixed monthly payments becoming a CapEx when a lot of organizations don't prefer to do CapExes. The variable returns from the GA and HOPE, we just talked about that. So when an organization is asked to make a commitment to a fixed monthly payment, it's only natural that the financial people say, well, if I'm making my fixed monthly payment, what's my return on investment? And the moment that answer is, well, it's a variable and we don't know precisely month to month what your investment's going to be, or your return's going to be, pardon me, you can see where these kinds of things fall off the rails relatively quickly. Some of the other major concerns have been roadblocks are the cancellation clauses and the end of life disposal of the systems. Obviously, with COVID, we've seen over the last couple of years in particular, certain industries seeing changes to their consumption. So this again is just one of those other variables that if you're asking me to make a fixed monthly payment, then this is a variable that doesn't suit us extremely well. The next thing we're looking at, oh, sorry, I wanted to go back to those ones. Just can't see them. Is the in the normal or traditional roadblocks, the way in which the opportunities were presented as project developers to end users was that the risk was squarely on the shoulders of the end user. And with all these variables that we're speaking of in terms of fluctuating GA and whole pricing, the fact you don't want capex, it's putting all the risk has been on the end user in the past. And I think the final thing that is a big concern for a lot of folks is that this is wonderful that we can employ these kinds of technologies, but what about the cybersecurity? Who can hack into our systems and who can hold us for ransom and interrupt our processes? So these are some of the very traditional common concerns that have prevented people from moving forward with battery storage. What we wanted to talk a little bit about with you folks is, why you want to engage with Edgecom Energy, and particularly as it relates to battery storage. What we've done is introduced just this January a brand new program. We call it Demand Management Rebate Program. And this is a new business model. And for lack of better descriptions, this is a paradigm shift in how you would have done business in the past as it relates to your electricity costs. The other reasons that, and I'll get into more detail about that in a moment. The other reasons why you might want to consider Edgecom Energy is that we have an in-house engineering and procurement and construction team. What this does in terms of an overall project is it allows us to keep all the costs in-house. We don't have to go out to get someone to provide us peak prediction. We don't have to go outside to do engineering, civil engineering, or construction. We do it all in-house. This keeps our costs down. Of course, that can benefit the project overall. The other major component is that we also have an in-house software. We have a team of data scientists that are experts in this technology. And we've proven it through the years that we have an accurate GA peak prediction, as well as predicting the whole prices for the grid. The other major benefit of working with Edgecom Energy is at this moment, we're the only ones, I believe, that have a true blockchain network operation center. This is a tamper-proof solution so that when you utilize a battery storage system from Edgecom Energy, you don't have to worry about any cyber attacks. The one thing I would also mention to you is that there was a recent award we received just in 2021. It's the Green Energy Award, and this is a quote from the Ministry of Energy, and this letter is available to share with anybody at any time, but basically the quote is, I'd like to congratulate you on receiving the 2021 OSEA Clean Tech Award in the battery storage category. So this is something that, what we're representing here in terms of the blockchain and all the in-house expertise. This is what's earning us the attention with the Ministry of Energy. So I'm going to speak to you a little bit more now about this new demand management rebate program. And this is, as I refer to it, the paradigm shift. So basically, you can continue to use the status quo, which would mean you just continue to pay your electricity rates at your consumption as you would usually do. Obviously, rates over a number of years could change and go up with your LDC, but basically the status quo would you just do nothing and you continue to pay your electricity rates. The paradigm shift as we're presenting it today is that you continue to pay the same rates with your consumption over the term of the agreement. And what we'll do is we'll install, maintain, and operate a battery storage system at your facility at no cost. And of course, what we're doing with that is that we're removing all the risk from you, the end user, and taking on all that risk ourselves. Before I get into the circuit energy, I just wanted to speak a little bit more about the demand management rebate program and how it's designed to help you. So basically, when we put that battery storage system in place, you're going to continue, as we said earlier, paying your electric bills just as if you would, as if the asset wasn't present. However, what you're going to receive beyond paying your electric bills as if the asset wasn't there is our expertise in managing and mitigating, whether it's GA charges or HOPE pricing, or even fluctuations in your consumption, uh, but also delivering at the same time at no cost to you emergency backup power. So this in and of itself has a lot of benefit to you. And then of course the utilizing the battery storage asset, we're also going to be able to reduce your greenhouse gases and show you how we calculate and document that information so that you can use it in your marketing. I'm going to turn the presentation at this stage over to our sister company president. His name is Sean Marhimi, and he will explain to you a little bit about the relationship between our sister company, Circuit Energy, and Edgecom Energy. Sean, would you like to take it from here, please?
Perfect. Colin, thank you very much. Good afternoon, everybody. Thank you for joining this webinar today, taking the time to listen in and grab some information about what's up and coming at Edgecom Energy. As Colin mentioned, we do a lot of things in-house, and that was the reason behind the inception or creation of Circuit Energy. It was to support as the execution arm to Edgecom Energy. So we're at heart an engineering firm, so we do a lot of the in-house design, implementation, procurement for all these battery energy storage systems. And I'm here to explain to you a little bit about the process that's involved, how this ties into your strategies in cost saving, and what you could expect. Some of the, I guess, questions that we hear a lot from a lot of customers. I'd like to point out the answers to those as well, and then we open up the floor to some questions that we could open up a conversation on answering some of your questions or concerns that you might have. On the next slide, I'll talk about the process that's currently in place for, I guess, the initiation of these systems. Typically, we'll start off with information gathering. We'd like to get a copy of your single line diagram of your existing switchgear, your electrical infrastructure and whatnot, to see how it's already set up, so that we could figure out where the tie-ins going to happen. A proposed location. Typically, a lot of customers might question this and say, well, where am I going to put these assets? And you could come up with a few ideas which will bounce off of you and figure out how things are working out. And then we get a copy of your bills and your interval data to evaluate in-house how this is going to play out financially for you. Then we'd ask with a preliminary proposal that we get a C-level sponsor on your side of the table. So we'd like to have that preliminary proposal with some of the numbers and what the rebate's going to look like, how the system's going to potentially look like. We'll make a few assumptions, obviously, and then we'd like you to come back with a decision maker's approval to proceed onto the next level, which is a site visit and firming up that proposal. So that is I guess the natural progression from the day that you express interest to when we come back with a firm proposal on the numbers, which could then evaluate whether this is something that would need for us to further investigate. Off to the next slide, I'll talk about, I guess, some of the questions that typically come up. There are two different types of systems that we typically propose here, UPS versus PCS. It's worth mentioning that I'd say 95% of our proposals and projects in the past have been PCS, but they both have their cons and pros. And on the UPS side, if you've got a very sensitive facility where it has to be always online, can't even have 100 milliseconds of drop in voltage and whatnot, then we'll look at a UPS system. It's instantaneous dispatch, meaning that our network operations center would be able to bring on the UPSs and the batteries that are connected to those UPSs as quickly as electrons move. It's got a simplified connection impact assessment process where we don't have to really provide that many details to the utility or to the local distribution company as far as how the system is going to be set up, because it's only a unidirectional feed. there's no way for us to inject energy back onto the grid. And that's, you know, one of the biggest advantages of UPS, especially when we're dealing with a utility that's not a fan of distributed energy resources. But then on the other hand, there's obviously the price, it's more expensive, and it also limits your participation ability. You won't be able to feed back onto the grid, which would then eliminate a lot of the programs that may become available in the future for you know, arbitrage and hope and whatnot. But on the other hand, you've got the power conversion system, which has a better price point. It's got flexible participation, where you could, you know, potentially participate as a feeder onto the grid or as a load. It's got a much more straightforward installation. But then it's got its own cons as well. You have to break from the grid before you bring on the batteries. And typically the utilities question a lot of things when it comes to the connection impact assessment. Not something that we haven't dealt with in the past, but it's a lengthier process, for lack of a better term. This leads to a question of real estate. A lot of times customers start asking about, well, how big are these systems? What are we looking at? We have tight spaces, and we want to see how long or how much of a real estate would a system like this would occupy. Obviously, the question would relate to the size of a system, which on the next slide I'll have a few examples on what a typical size of a system would look like. For some reason it's stuck, but if I go to there we go. So to give you an example, so let's say a 1 megawatt system would have 6 cells in it. Each cell is about 225 kilowatts, and they take about 4.5 by 6 feet of space. So if we put them all together at about 10 feet high, so we put these cabinets side by side as a two-dimensional top view of what it would look like. But it's just like a 1 megawatt system. You'll be looking at a 12 feet by 14 feet in size. A 2 megawatt would go to a 12 by 23. And the nice thing about the technology that we use is that these could be double stacked. So in the case of a 5 megawatt system or 5 MVA system, we will be looking at a 12 by 28 feet footprint, but then it'll be double stacked. So we'd have a total of 12 cabinets on the ground and 12 cabinets right above them. And in a 10 megawatt, the same thing. You'll have 2 platforms, each 12 by 28, and double stacked onto one another to a maximum height of 20 feet. We'll evaluate and discuss a lot of these options with you once we get your C-level executives, a sponsorship from your end to say that, yes, we want to hear more about it, want to get a firm proposal. We'll have our engineers come on site and take a look and basically come back with a firm number and a firm proposal on what the system is going to look like, how many cabinets we're going to get, where is it going to be located, how is it going to tie into your systems, and so on and so forth. But ultimately, this is what we would expect in a typical project before it gets to a stage that we need to come on site and do a site visit and so on. We wanted to keep this short, so that's about 20-22 minutes, so that nobody starts snoozing. But at this point, we wanted to open up the floor as well to see if anybody has any questions that we could address. Again, I wanted to thank you all very much for your time. But that's, I guess, in a nutshell, what it is that we're pitching and we're hoping to work with you on.
Okay, so thank you again, folks, for your time. And this is an opportunity to ask some of your questions. If you want to go ahead and unmute to your own access point and ask your questions, we'll do our best to answer your questions for you.
So Mike, Colin, there's a question about the ROI of the system, if you want to take that.
Okay, so what is a typical ROI for these systems? So that's a great question. The way this system is working is that there's 2 major components to this project. Of course, the actual asset cost for the battery storage and the whether it's a UPS or a PCS, sorry. Once we know the equipment costs, we need to zoom in on the installation costs, and those will be different at each facility. And so in terms of the return on investment, basically you're not making an investment. That's the interesting paradigm shift here. There's no investment on your part. You're going to, as I said, status quo, you're going to pay the going rates for electricity whether you do this or you don't do this. And if you do this, you're going to continue to pay the same rates. And maybe I didn't explain it clearly enough. What would happen in that scenario is that um, basically we will create every month for you an alternative bill. And the alternative bill will be based on the exact same rates that you're paying today to the LDC, as if the battery wasn't there. So for easy conversation, let's say you had 100 kilowatt hours of consumption, and the going rate is 10 cents per kilowatt hour. That's what your bill is expected to be. With our system in place, you continue to pay over the term of the agreement, you continue to pay the 10 cents per kilowatt hour. And what will happen is that once the asset begins to reduce your overall costs, you're going to receive a regular bill from the LDC, and you're going to receive what's referred to as the alternative bill from Edgecom Energy. So the alternative bill and the bill from the LDC will be a difference. We accrue that difference for you on a month-to-month basis. And then based on how much that financial benefit has been acquired by the asset, we will make an actual rebate to you at the end of that quarter. So in terms of return on investment, there is no investment on your part. We put the asset in place, we operate it, we maintain it, we generate the savings. And once the savings is generated, then we accrue the difference that the asset is delivering financially. And then we analyze it and give you a quarterly rebate, and that quarterly rebate will be set up on a predetermined project percentage. So when we do the preliminary investigation, we're going to find out two things. We're going to find out what term it's going to take to make this project work, and then we're going to determine what percentage of the savings on that term can go back to you as the customer. So once that's determined, we make some agreement for the duration of that term, and over that term, we're going to use a monthly alternative bill, and we're going to calculate for you what that asset delivered in savings to that facility, and then we'll have the predetermined percentage of that savings going to you as a rebate. So there is no return on investment. This is the unique paradigm shift here. The end users don't pay Edgecom anything. They just continue to pay their electricity bill as if it was not in place. I hope that answers your question.
Great. There's a question from Adrian about completed projects and relevant details. We're currently in process of a 1 megawatt project in the Ottawa region. We've got another one at 500 kilowatt in Mississauga that's in progress. And we've done a few other projects in the past with our partners that we would be happy. But they're mostly, we had a different business model in the past, but the new projects are going to be under that rebate program that Colin has mentioned. Mike has asked about Class A or Class B customers. Typically, we're after Class A customers at this point, mostly because of the global adjustment line item that's available at this point. As hope prices change and as the programs shift, we're potentially going to be opening up the availability to Class B customers as well, depending on what sort of programs would be in place by the IESO for Class Bs. But at this point, it's only for Class A.
Sean, if I could add to that, please.
Yes.
The one interesting thing here is that in theory, if you're close to being a Class A customer, 450 kilowatts of demand a month, in theory, the battery could be utilized to, put it on a couple of times a month just to make sure that you have at least 15 minutes in that monthly period where your demand is over 500, and in essence, making you become a Class A customer. However, the reality here is that the majority, as Sean mentioned, the majority of the savings or the payback for the project is derived from avoiding GA costs. So if you have a smaller GA costs, in essence, once we evaluate the project, it's going to do two things. It's going to push out the term longer, and it's also going to reduce the percentage going back to you. So it may become to the point where it's not viable to do that, but you can be a Class B in theory. But the smaller you are, the more difficult it is to justify the project, if that makes sense.
There's another question about that down the line, but I'll answer Vic's question, and then you can take on the next one. So yes, Vic, UPS would be an uninterrupted system where it's always online, and it could be in a charge or discharge mode, or it could bring the batteries into charge or discharge mode remotely. The PCS that we have currently, they're all islanded, yes. So they go on a break before make configuration. So there's no possibility of it feeding back to the grid, but it's usually less than 100 milliseconds. Typically, a lot of facilities have embedded protection to to weather that sort of a blip, less than 100 milliseconds or so. But yes, that's correct. Colin, do you want to take that next question? What is the requirement? What exactly is the required term commitment by the customer? What if the GA program changes?
Okay, that's a very good question. And this is perhaps one of the reasons why a lot of these projects haven't gotten off the ground in the past, is that the GA is a variable. It can be up and down. In theory, it could go away. We believe very firmly here, as energy experts, that if they take away the GA, that means the hope price. If GA goes down, hope is going up. If they take away GA altogether, they're going to have to create some sort of incentive program with the hope pricing. And we believe strongly that regardless of what they do, the grid is getting under more and more demand. Once the electric vehicles come, once the refurbishing comes, where is the energy going to come from? And the IESO, the government have been trying to pave the way for more DERs on the grid. And so we believe strongly that we don't know for certain, and you're absolutely right, there's no certainty where the GA is going, but there's going to have to be some way to balance the grid. And those who are, quick to adapt this, this technology and get involved, the more likelihood that they're going to see the grid rewards. There's going to have to be something in place to offset these demands on the grid, and DERs and battery storage in particular is the cleanest and we think one of the more functional assets that can be accomplish these goals. So there is no certainty, and that's why this demand management rebate program that we're offering takes that risk off of your shoulders. You don't have to worry about that. That's all on us. If we put this battery in place for you, we get a term, we get a agreed upon percentage of the savings coming to you as a rebate, and the rebates don't happen for whatever reason, the asset doesn't perform, then you continue to pay as if that asset wasn't there anyway. So the risk is really squarely on our shoulders, and we believe firmly that we can deliver value. I mean, Sean alluded to one of the other things that's coming up in the near future for a lot of people, and that is registering these assets as dispatchable. So we know that GA is a good stream of revenue. We know that demand management through the capacity auction, or demand response, pardon me, through the capacity auction is also one. But the other alternative is to also participate as an operating reserves dispatchable asset. So we can move to get these assets registered and just deliver another stream of income. So once we have that term set up, and only through looking at the number of cells required to get the megawatts, and also the potential installation cost, well, we know what that term is going to be. But once we present you with the term, it'll come along with a percentage of the rebate that we believe we can give you to make that project viable.
Very good. There's another question from Vic. Can it be used as a backup power? Great question. So there are a couple of parameters that come into play when you're designing a battery system solution, and one of them is the number of cycles that it can be charged and discharged. And historically, what we had to do was to limit the number of discharges, because we're primarily focused on capturing those global adjustment coincidental peaks that we had to discharge the batteries for. So it would limit the number of cycles to a certain number that would make financial sense. But now, as things shift towards more hope driven grid rather than global adjustment driven grid, we're going to be looking at increasing the number of cycles. So in our provisions, we don't typically ask for a backup power, because not only the batteries have a limited number of hours of available power. In our case, we're typically looking at only about 2 hours of discharge. But also the life cycles of the batteries dictate how long they will last throughout the period that we're looking to have these projects for. So to answer your question, yes and no. It really depends on a customer case by case and how long of a backup power you'll be looking at. But that really would depend on the configuration and how the finances work. Would you be open to a Class B customer that may be willing to provide some capital to offset the GA not being there? Colin, do you want to take that?
I'm sorry, what was the question?
Would you be open to Class B customers that may be willing to provide some capital to offset the GA not being there?
Sure. Actually, we're open to look at any project, and that's the whole idea. Is to, we need, as Sean alluded to, we need some preliminary information to determine what the size of the asset is, you know, what the installation requirements are going to be. And once we have that number, we can share with you what the term would end up being and the percent sharing is coming back. If there's somebody who wants to put some funds into that project as well, it can impact both the term, shortening it, and it can also increase the percentage of return. So yeah, we'd be open to look at that with people for sure. I just want to go back to the previous question, if I may, a tiny bit, expand on that. That was related to backup power. So this our assets are managed through our network operations center, which is blockchain. So it's secure, and the only one who can get into that is ourselves. So in the event that the grid is running and there's a blackout on the grid, then the battery will automatically kick in and provide that backup power. I think where we often get questions is, okay, so now I know I'm going to have emergency backup power. Would I have backup power available for scheduled maintenance and so on? And the answer is yes, we can talk about that. It's not something that you as the end user can turn the system on and off yourself. You'll have to make a request through us as the network operations center manager to actually set that up. And it's not hard to do. We just need to coordinate and have time, notice ahead of time. And so, yes, you'll have emergency backup power if something happens on the grid for the long as the battery will last. And then if you want to have access for other purposes, there's a limitation. We can't have you, running off the battery all the time, but and then just degrading the life of it quicker. But there's room for negotiation in there, and there's lots of opportunity, I'm sure.
Yeah. Jonathan's asking, do we need a connection impact assessment application to our LDC? So that's part of the services that we offer. It is included in our packages that, yes, for the PCS system and both the UPS. The UPS is a much easier process because it's not a bi-directional asset, whereas the PCS is a bi-directional asset. So we would need to submit a connection impact assessment to the local distribution company. Typically, it involves our protection philosophy, the type of switches, and their ability to be able to isolate the batteries if need be at any point in time without the intervention of our network operations center. The next question from Anthony, do you automatically dispatch the battery according to your PTRAC system so the site staff don't need to be actively responding to curtailment at site? We have that capability through our network operations center. As Colin mentioned, it is a state-of-the-art blockchain secured dispatch protocol that we have in place that can remotely dispatch these assets when need be, so that they take over the load of the facility during global adjustment peaks or coincidental peaks, or during hope period.
The short answer to that question is basically it's a blind eye. The asset is in place, it's monitored through our network operations center and dispatch. So to answer the question, yes, we're automatically doing it for you. You don't have to do anything else.
Vic is asking if islanded, no CIA. So islanded by the means of operation of the asset. The PCS by design has the ability to feed into the grid. So they do require that. What I mean by islanded is the actual dispatching of the asset would happen in an islanded setup where we would disconnect from the grid, and there's a SCADA in place that would allow us to pull back onto the grid when we're ready to go back. So there is a CIA requirement that we need that. And then Gord is asking, do you have a proven reliability of your battery packs and what is the expected battery life? So this is a very modular system. And what I mean by that, not only it's an N+1 redundancy setup, where we've got modules that are there just to back up any potential failures within the internal components of the battery, but we also remotely monitor the health of each cell. So we proactively, I guess, tag and replace any cell that could potentially be problematic in the future. Again, the typical expectancy before a major overhaul is about 10 years for the batteries. Correct, Colin? That's what I have in my in the past.
That's correct.
Right, but as I said, if anything were to happen in the interim, we would flag it before it even happens through our health monitoring protocols that we have embedded into the batteries, that we could flag and replace the modules as we go without any interruption to the service. They're basically drawers that are filled with lithium-ion batteries, and that would just be able to remove out or move out a particular drawer and replace it with a new one or refurbished one to carry on that setup. Vic is asking again if islanded must be sized for the entire downstream load. Correct. If we are to take the entire load of the facility, that's what we usually do. I'll give you an example. The project that we're doing in Mississauga right now for a 500 kVA, 450 kilowatt system. It is set up in a way that we actually provide them with, their load is just over 450 kilowatts, but we provide them with a curtailment action plan. So they basically lower some of the loads they can remotely, and then the batteries take over the rest of the load for the entirety of that 2 hours that the batteries can take on their load. Can we get a recording of this? Sorry, say that again.
In terms of the GHG offsets,
yeah,
part of our network operations center and our portal is that when the asset has created a curtailment event of any kind, whether it's for ICI, whether it's for the demand response capacity auction, and or it's mitigating hope pricing, every action removes a certain amount of greenhouse gases from the grid at the moment in time. And so on the portal is an actual, it shows you what you actually curtailed, what the amount was, and then a corresponding greenhouse gas reduction. And then we go further to into our sustainability offering to help people who want even more depth or granularity. We offer the ability to put sub-meters on different devices and isolate the individual devices to identify the greenhouse gas emission reductions from the individuals as well as an overall for site quantity.
And that next question might also be best answered by you, Colin, since you explained the program. So Dave is asking, what percentage of savings does Edgecom take?
There's not a set percentage. What we're looking at is to build a viable project. Obviously, the advantage to the end user is that you're not paying a dime to acquire the emergency power backup and have the asset on site. We're taking the risk of putting that on site, so we need to evaluate. Each project is an individual agreement that we have to come to, and it may be that it's a very simple installation and only one transformer required. It could be that it's a very complicated installation and be multiple transformers, maybe even require multiple buildings on a campus that requires different sites. So it's quite complicated. We don't set ourselves up to say we're taking X percent. We're trying to make a viable project, and then the variable will be typically the term is going to be required to make some sort of contribution in terms of a rebate to you, and have something that covers off the cost of the project as we go forward. So it's not an easy answer to say it's X percent. It's a project by project basis.
Justin's asking if a Class A customer can offset GA with current on-site generation. Are projects still viable through other programs such as demand response? So that's a good question, Justin. I assume that by on-site generation, you mean, let's say, if you've got a gas generator or whatnot that you're currently dispatching during those peak hours. The project that we're doing right now in Ottawa is a prime example of that. They've actually got CHP on site that they're using in parallel to the grid. And the remaining balance of what they could not curtail through their CHP is what we're taking on through the batteries. So it still has to make financial sense for the investment to be in place. There has to be a sizable outstanding demand on the facility for us to be able to make the project financially feasible. But any program that's available is up for grabs through these assets. So if it's demand response or arbitrage or global adjustment, hope, whatever program is available through the IESO, we'll go after with these assets. The only caveat here is that we have to make sure that there's an understanding that there is a need for that amount of outstanding demand to remain when the batteries are going to be dispatched. To better explain that, we can't have a 1 megawatt battery and basically size the project based on a 1 megawatt battery and then realize that down the road that your outstanding balance of demand is only about 500 kilowatt. That will throw the entire project off balance, and it won't make financial sense. Colin, do you have anything to add to that?
No, I think you covered that one pretty well. Thank you, Sean.
Yeah. I don't see any other questions, but I believe you all have our contact information.
There's one more here, Sean. It says for loaded LDC TS for CIA, is there a different shortcut test for of UPS versus PCS?
So where's the question? Can you read that again? I don't see the question here.
It's from Vic, and he's asking for loaded LDC. I don't know what TS is standing for here. For CIA, is there a different short circuit test of UPS versus PCS?
Is there a different short? I don't read the question here. So, is there a different short circuit test
for UPS versus PCS?
A lot of these short circuit tests and the ratings that need to be in place are typically demanded by so part of the process is that we submit a ESA plan review. So the Electrical Safety Authority looks at our plan and the engineering and the single line diagram. So if loaded LDC transformer can PCS work? Oh, I see what you mean. Okay. So if it's loaded, here's a question that comes to mind, which is how are we going to charge the asset, right? So if you've got a loaded transformer, we may need to upgrade that transformer to be able to allow for the batteries to be charged at the time that hope is near zero. So typically, if you're at a point that so if you're at a point, if it's not a customer transformer, it's a local, if it's LDC's transformer, we may have to request an upgrade. So that obviously is could be a potential deal breaker depending on where we're at. Sometimes facilities size their transformers at the time that they open up, and then they outgrow that pretty rapidly. Yes, you do need that both because remember, the battery is not just a source of power, it's also a load when it needs to be charged. So if your transformer is loaded above 80%, I think it's above 80%. I have to double check that with one of my electricians. But if it's above 80%, then you would need to upgrade your transformer so that with the additional load that the battery presents to the utility side, you won't be overloading the transformer. I hope that answered the question. Well, gas generator is not a load in the eyes of the facility, in the eyes of the utility. It's a source of power. There's no, that's correct. There's no need for your transformer to be feeding the generator per se, right? So with a natural gas generator that you're putting in, we're doing another project that was basically, it's still on hold, but it's a 6 megawatt system in Brampton. And that was a natural gas system. And that required a CIA on the basis of the closed transition system that we had put in place to minimize the amount of transition time to less than 100 milliseconds. But anyway, we'd be happy to discuss that offline if you'd like to. Anyway, I don't see any other questions. Colin, do you see anything else? If for some reason that last question didn't pop up on my screen, but.
No, I think we've answered all the questions for today.
Yeah. Okay, great.
Take a few minutes and just thank you as we depart, everybody, for taking the time to join us. And please feel free to reach out if you have any further questions or would like any kind of understanding. We will be sending out some further documents as well as a copy of the slide deck, and leave it at that. Sean, did you have anything you want to add?
No, I think Vic would be happy to set up a follow-up call. I think Colin will set that up, and I'll be happy to join as well, answer any questions. Again, thank you all very much for your time. We appreciate it. We look forward to working with you on the projects. And then, well, that Greg can be loaded above 80%. So it's not my area of expertise when it comes to ESA requirements and whatnot. But thank you very much for that clarification, Greg. Appreciate it. All right. Have a great day, and we'll all be in touch. Take care.